Hey guys, okay, I just want to go over a couple of things with experiment 3.2 because a few of you got confused. So what you're going to do is you are going to mark from Phoenix to Bismarck on your map, and then you're going to measure that, right? You're also going to set up an X and a Y axis so that you can get your angle, right? So I did this and I have a measurement and I have my angle. With that, I'm able to get my X component and my Y component, okay? The next thing I'm going to do is I'm going to take my ruler and I'm going to draw a line from Bismarck to Washington, D.C. And I'm going to get a length again. I'm also going to get an angle. And this angle is if here's my x-axis, here's my y-axis. So it's going to go all the way around to get my angle. So because you're using a protractor, the other way you can do it is you can line it up, get what this angle is, and subtract it from 360, and that's going to be your total angle. Okay, so my second angle was in the ballpark of 330, 340, something like that. All right, so you're going to get a high angle. Then you can take your magnitude, right, the length of your arrow, then you have your angle just like in the first vector, and you can get your components for bx and by. So in the first one, you're going to get ax and ay. In the second one, you're going to get bx and by. And then what they want you to do is they want you to add them, okay? So you add your x components and you add your y components, and then you get the magnitude, and then you take your formula and you get your angle, okay? The last step that they want you to do is they want you to actually take from Phoenix, draw a line straight to Washington, D.C. What do you get if you just took this? You make your x and your y-axis, you get your angle, then you measure and you get your magnitude, right? And then they want you to compare with when you got your first, your second, and you added it versus doing it directly. And they want you to see how they compare. And they should be close. There's going to be some margin of error, usually because of significant figures, but they should be close. Hopefully this helps you if you want to do your next lab report, understand exactly what you're supposed to do. I know there was some confusion with some of the angles, but there you go. All right, I'd like to go over a few of the practice problems. So one should look very familiar. It was on your quiz. It says graphically add the following vector. You're going to move the second vector, so the tail is at the head of the first. So you're going to take B, move it, so it's at the tail. So I like to draw it here just to give me more room. And then you're going to start at the tail of the first vector and go to the head of the second vector. And that dashed line is going to represent A plus B. Graphically subtract vector B from vector A in problem 1. So you're going to flip B to make it negative, and then you're going to follow the same process where you move it, and then you're going to go from the tail of the first to the head of the second, and that dashed arrow is going to be A minus B, okay? Number 3, the velocity of a plane is pictured below along with the velocity of the wind through which the plane is flying. Graphically show the final heading of the plane. Okay, so they give you its course, and then they show you the wind. So I added the wind, my second vector, right here. And then I draw my dashed line. Okay, so I put the tail of the second vector at the head of the first, draw my dashed line. That's going to be the plane's true velocity. Number 4, vector A has a magnitude of 35.1 meters per second and a direction of 215 degrees. What are its x and y components? All right, this is you just plug it into the formula. So the x component is 35.1 meters per second times cosine of the angle, 215, and I got negative 28.8 meters per second. The y component, 35.1 meters per second, sine of 215 degrees, and I got negative 20.1 meters per second. All right. In 5, the velocity vector of a car has an x component of 17 meters per second and a y component of a negative 11 meters per second. What are the magnitude and direction of the velocity vector? So for the magnitude, I just take my formula and I plug in 17 meters per second squared for the x component plus negative 11 meters per second squared for the y component, take the square root, and I get 2.0 times 10 to the first meters per second, dealing with significant figures. Now we need to get the angle, so we use the equation, the angle equals the inverse tangent of Vy over Vx. I plug them in and I get negative 33 degrees. Now remember we talked since x is positive and y is negative, we're going to be in region 4, so we need to add 360 degrees in order to get the correct angle. So my answer is going to be 2.0 times 10 to the first meter per second magnitude with a direction of 327 degrees. All right. I'm just going to do a couple more. I think you guys get the idea. For number 6, it says vector A has a magnitude of 31.1 meters and an angle of 160.0 degrees. Vector B has a magnitude of 11.4 meters and an angle of 290.0 degrees. What's the sum of these two vectors? And I worked it out here on the back. You just use the formulas that we talked about in class. So your x component for the first, ax, is going to be 31.1 meters times the cosine of 160.0 degrees, and I get 29.2 meters. And my y, let me just make sure really quick. Yeah. And my y is 31.1 meters from sine of 160 degrees. I get 10.6. Then I do the same thing for my other vector, and then I add them. Okay, I add my x components, and then I add my y components. And then to get the magnitude, I take my formula, cx squared plus cy squared, square root, and I got 25.3. Then to get the angle, I do the inverse tangent of this added component over the cy, which is both of them added, and the cx, which is both of them added, the x components. And I take the inverse tangent of that, and I got 0.2 degrees. The x and the y components were both negative, so it was in region 3, and I needed to add 180 degrees. So my angle is 180.2 degrees. All right, these are just a lot of plug and chug, working it out. Just know your formulas. Let me take a look at your test and see what hints I can give you. All right, so hints for your test. You're going to need to be able to do this, to graphically add vectors. You're also going to need to know just how to understand this. What represents magnitude? What does the angle represent? Which of these would have a bigger magnitude? Those kinds of questions. You have a problem very similar to this, so make sure you understand it. It's not quite the same, but it is very similar. If you are given a vector's magnitude and its direction, you need to be able to get its x and y components. So know the formulas and be able to do that. And then, of course, be able to add vectors when you're given their magnitudes and their direction degrees, but also be able to go backwards. Okay? Let me know if you guys have any other questions. I think we pretty much covered everything in class. Just practice a few of the problems. Make sure you understand it before you get to the test and know your formulas. All right, I'll see you on Monday.